The tables and relationships in your database are just like the data and relationships in life. You are just capturing a snapshot of life through the service you are building. What I mean is that since everything in this world revolves around people, everything in your database will revolve around people as well. You may store them in one table or many. You may have separate users table and customers table, for example. However, most of the records will refer to one or the other. To demonstrate that, let's first create table of users. New table, and the first column will be primary key, length of 7 typically. Then there will be some kind of login username. Let's give it 20 characters, 120 characters. And then maybe email address. And let's save it under XX user. So now I can go and add some users. The first will be Anna, gmail.com. The second will be Tom. And the third will be like Peter. Now think about it, because my application, my system is all about users. Wherever I do, I will probably link to those records, key records in my database. So for example, if I'd like to store answers to questions, the first column will be question, answer, but the second column will probably be user ID, because a user is answering those questions, right? So I now have question answer table, but this table actually links or should link to user table. So I'm going to do that. I'm going to foreign keys and I'm going to create a constraint. That will be the name of the constraint, and I'm linking this user ID field within the same database to my XX user table and its user ID column. So I have first link. But then I want to introduce payments to my system, and so I create a new table and it will be called XX payment, and that will have payment ID key. But immediately the next column will be user ID or some kind of payment user ID column linking to, well, it should link to the user table as well, because the payment is made by a user in my system. So again, foreign key, that will be the name. And I'm linking that column from the XX payment table to my, again, user table, user ID, and that's second table, XX payment, also linking to XX user table. But it can get even worse. Let's think about what kind of functionality for my website I'd like to have. That could be a blog. I'd like to have a blog, and this blog will have articles. So I'm going to create a new table, and that table will have primary key of article ID. And obviously that article will have maybe title. Let's give it 20 characters, 120. We'll have some body maybe or content. And that would be text, long text field. But then I will immediately have columns referring to users. The first could be author user ID. So that would be first column that links to my user table, but not only that, I could have the whole review process, and those will be different users. So I would have, for example, first review user ID, and I could have last review user ID, and I could have final review user ID, and I could have last update, that not date by user ID. So now block, I'm saving this table as XX block article, and I am having one table with 5 or even 10 columns referring to XX user table again. But the concept is even more general than that. In nearly every database, you'll find a few fundamental tables that are crucial, with everything else referring to them. For an e-commerce store, these would include products and purchases, for instance. For a blog, it could be a table of articles. For a mobile application, it might be user registration. Even though your database might ultimately contain hundreds of tables, they will all dance around these key few. This setup has many important implications. The first and foremost for us is that the records from these key tables, whether they represent users, products, or customers, will serve as the main data dictionaries. In their relationships with other tables, they will most often take on the role of parent records. And with time, I can add more and more tables as I wish, as I need, to my system, and most of the tables will have some kind of column referring to the XX user table. And at that time, I may not realize that I'm actually building some kind of database architecture. Only after I go to my relationship diagram, I can see that those tables are referring to XX user table, which is in the middle, and I'm creating some kind of diagram structure that is similar to snowflake or star. But if I now go to Wikipedia, I will find out that this is no coincidence. This actually is the most commonly known data structure called star schema or star model. And it's not that it's right or wrong, it's just because I'm trying to reflect reality with my database structure, and the reality is that in most applications everything revolves around users. But if so, then I should be able to go to my startup, to my production database, real organization database, and look for the same thing. So in here I can go to list of tables, and in here I can search for all tables that have user in it. And there will be around 70 tables that refer to user, like user images, for example, or user tasks. And most of those tables will have some kind of user ID column, or many columns linking to user table. But now think about that. If my startup, my organization is actually e-learning platform, so a school with social network capabilities and gaming functions, then it will not only be about users, there will be other entities that this functionality will revolve around, like for example image, because users, mothers, can upload images. There will be groups in which they learn. There will be registrations. There will be courses. There will be maybe other things, but let's take those 4. So if so, then I will find many tables that also link to those. And if I go to table, and if I look for group, indeed I have around 25 tables linking to group entity. And then if I have image, there will be even more tables linking to images. You can have user images that would be images of users, but those tables will link to images as well. Let's go here, let's go to design table, and you will have user ID, but you will also have ID, which in this case is image ID. Then you will have course. You can see there will be around maybe 40-50 tables linking to course, and then registration. There will be 5 tables linking to registrations. So what's the conclusion? Well, you should now understand that A real-life database of an organization that actually functions will not be a uniform list of tables. It will rather be a set of islands, stars, snowflakes that link together but are like islands of information, dictionaries that other tables link to. Alright, but why are we talking about this? Is it a problem? Yes, it's a huge problem. If all tables in a database are connected to a few central ones, and there can be dozens of connections, it means that no matter what queries you perform, you're always fetching records from these few tables. If someone else is editing them at the same time, your entire application will come to a standstill. No one will be able to see the value of a record until the new value has been saved. No one will be able to update a user record if other updates on that record aren't finished. This problem can't be solved by buying more servers or CPUs in the cloud. There are no miracles that would allow a database to predict the future. The only solution is a proper database architecture from the very beginning. And believe it or not, this is fantastic news for you. You can have a database faster than all your competition while spending a fraction on infrastructure. That's what I personally love about databases. They don't care about rank or position.